Hello, welcome to TechPre YouTube channel. In this video, we're going to talk about authentication and authorization in FastAPI with KeyCloak. By the end of this video, you will have a strong grasp of integrating KeyCloak into FastAPI for authentication and authorization. Let us quickly go over our learning objectives for today. Understand the fundamentals of KeyCloak and its role in authentication and authorization. Learn how to integrate KeyCloak with FastAPI. Implement role-based access control (RBAC) in a FastAPI application using KeyCloak. Secure API endpoints with KeyCloak OAuth2 and OpenID Connect. Test and debug authentication flows effectively. What is KeyCloak? KeyCloak is an open source identity and access management solution. Here is what it provides. Single sign-on SSO for seamless user login across applications. User federation to integrate existing user directories like LDAP or Active Directory. Identity brokering to connect with third-party identity providers like Google, Facebook, etc. Social media login capabilities for modern applications. Additionally, KeyCloak is standards compliance, supporting OAuth2 and OpenID Connect (OIDC). It offers role-based access control (RBAC) to manage user permissions easily. KeyCloak's admin console simplifies the management of users, roles, and clients, and it is extensible, allowing custom providers to suit your needs. So, why should you use KeyCloak with FastAPI? Here are the key benefits. To enhance security, KeyCloak centralizes authentication and role management, ensuring consistency and security. Scalability, KeyCloak integrates seamlessly with microservices like FastAPI, making it ideal for large distributed systems. KeyCloak eliminates the need to build custom authentication system from scratch. It supports OAuth2 and OpenID Connect, which are widely accepted industry standards. Simply put, FastAPI and KeyCloak make a powerful duo for building secure, scalable applications. This flow diagram illustrates the interaction between three components: browser or client, which initiates requests for login and API access; the KeyCloak server, which manages user authentication, issue tokens, and enforces roles. We have FastAPI application. This secure endpoints by verifying the access tokens issued by KeyCloak and implementing role-based authentication. This flow begins with the user sending a login request from the browser or client application to the KeyCloak server. The request typically includes credentials, for example, username and password. Then the KeyCloak server validates the user's credentials against its internal user database or a federated identity provider. Once validated, the server generates an access token and sends it back to the client. This access token is a JSON Web Token (JWT), which includes user details, roles, and expiration time. After login, the client includes the access token in the headers of subsequent API requests. For example, the request is then sent to the FastAPI application. The FastAPI application receives the API request with the token. It extracts the token from the authorization header and verifies its validity by checking signature, which ensures the token was signed by KeyCloak using its public keys, the expiration date to confirm the token has not expired, and also issue an audience, which verifies that the token was issued by the expected KeyCloak server for the intended client. FastAPI communicates with KeyCloak or fetches the public keys published by KeyCloak to validate the token. If the token is valid, it extracts user detail, for example, role and user ID, from the token payload. Based on the user's roles embedded in the token, FastAPI determines if the user has the necessary permissions to access the requested API endpoint. For example, admin role, which can access all endpoints, and likewise the user role, which can have a limited access based on business logic. If the token is valid and the user is authorized, the application processes the request and responds with the required data. If the token is invalid or the user lacks the necessary permissions, an error is returned. For example, 401 unauthorized or 403, which is for forbidden. Here are some key points to highlight. Always require an access token for sensitive APIs. Use KeyCloak's public keys for verification to prevent tampering, and also implement role-based access control (RBAC) to restrict access appropriately. This flow ensures robust authentication and authorization for your FastAPI application while leveraging KeyCloak's capabilities. By following these steps, you can protect your APIs, manage user roles effectively, and provide a seamless experience for your clients. Before we dive in, let us go over the prerequisite for this session. A basic understanding of FastAPI is required. Familiarity with authentication concepts like OAuth2 and JSON Web Token (JWT). Also, an installed KeyCloak server. We recommend Docker for ease of setup. Python 3.7 plus installed on your system. Additionally, make sure you have the following Python package installed. I already set up the KeyCloak on my machine using Docker. If you want to get yours done, here is how you can install and run KeyCloak using Docker. So this will start KeyCloak in development mode, accessible at port 8080. Like I said earlier, I have the KeyCloak installed and running on my machine through Docker. Now let us log into the admin console on our browser using the local host 8080. So you can see the KeyCloak admin dashboard. Impute the KeyCloak admin password and username, which is admin. So admin, password, admin. So the username is admin, likewise the password is also admin. So let's sign in. Now we successfully signed in. So the next thing to do is to create a REM. A REM is a critical component in KeyCloak that acts as a container for users' credentials, roles, and groups. It allows you to isolate authentication and authorization settings for different applications or organizations. As you can see, we successfully log into the KeyCloak admin console. I already created a REM called FastAPI REM. If you want to create a new REM, click on Create REM. You can create your REM name. We open the browser and navigate to the URL of our KeyCloak instance, right? Then we now log in using the admin credentials. And if you're setting up KeyCloak for the first time, these credentials were configured during the initial installation. On the left hand sidebar, ensure that you are viewing the current master REM, right? The master REM is the default administrative REM created during KeyCloak installation. I already created the FastAPI REM. So to create another REM, we are naming this FastAPI Dev Mode REM, right? We are not going to use it. We are still going to use the initial one that was created, but just for you to see how it's being created. So we're going to create this and delete it immediately. So click on the create button. Now let us set up a client in the KeyCloak for your FastAPI application. The client represents your application in KeyCloak, enabling it to interact securely with OpenID Connect. This setup will enable confidential access for authentication and authorization. Open the client page and click on this create client button to add a new client. Fill in the required fields. Enter unique identifier for your client. In this case, use confidential client. Sorry. So this is optional. You can provide a user-friendly name for your clients. This helps in identifying the client within the KeyCloak dashboard. And also, you can add a brief description of the client, such as Fast API application for authentication and authorization. Turn on the client authentication. Likewise, select the service account controls. Then we click on next. You can provide the root URL, home URL, valid redirect URL, valid post logout redirect URL, web origin. But in this project, you're going to leave this as it is without imputing anything. This admin URL is optional. This is a callback URL that KeyCloak uses for administrative actions related to this client. For example, you can set this to your FastAPI application-based URL or a specific endpoint, such as this. So let us save. You can see client successfully updated. So successfully save this. Roles in KeyCloak are used to manage and assign permissions for users within a realm. As shown on the screen, we define an admin role which grants full access to perform CRUD operations, create, read, update, and delete on user and system configuration. This role will be essential for administrative tasks and manage the platform effectively. Let's go to our KeyCloak admin console and create a new role. So here we click on this realm roles, then click on create role. You can see we enter admin as the role name. This is the identifier for the role and will be used to assign it to users. Provide a detailed description for the role. For instance, now click save. You successfully created the admin role. Ensure the description clearly communicates the purpose and scope of the role for future reference. You might be like, what are the benefits of defining roles? Clearly defined roles ensure users have only the permissions necessary for their responsibilities. Likewise, assigning roles simplifies user management across the platform. As the platform grows, roles can be reused and associated with new features or user group. In KeyCloak, users are identities that can authenticate and interact with your application. By assigning roles to users, you control their permissions and define their access scope within the system. Let us create a user named Anne and assign her the admin role. In the left-hand navigation menu, click on Users. It opens the user management page. Now let's create new user. So let's name this user Anne. The first name we can say Anne, then the last name Doe. Provide an email address just like this. It's optional, but you can just provide an email address. Now let's click on create. The user has been created successfully. Now let's navigate to the credentials tab to create password. Just create a simple password. Insert it. Input the password again. 1, 2, 3, 4. Okay. Can you see? We don't want to reset the password upon the first request. If you select the temporary option, that means you want the user to reset the password upon first login. So let's turn that off because it's not needed here. So click save and save password. The password has been set successfully. Now let us assign a role to this user. Navigate to the role mapping tab. Click on the assign role button. After clicking on the assign role button, you'll see filter by client. Now change this to filter by realm roles. Now click on admin, then assign this role to Anne. You can see we successfully assigned the admin role to Anne. Just as you can see on the screen, in the role mapping tab, ensure the following roles are assigned to Anne. The default roles, these are predefined by KeyCloak and provide basic permissions, and the admin role, which grants Anne the ability to perform CRUD operations and manage the platform. Double check that the roles are not marked as inherited unless intentionally configured that way. Role-based access control, RBAC, is a security module used to assign permissions to users based on their roles. It enforces the principle of least privilege, ensuring the users only have access to the resources they need for their task. This guide demonstrates how to implement RBAC in a FastAPI application with two roles, admin and developer. each having specific access permission to the API endpoint. The admin, which is the username, and has permission to create resources, read resources, update resources, and delete resources. Let's proceed with the implementation. So to get started, you have to first install all the libraries that are going to be required in this project. I already have all the code base ready. So all I'm going to do is to explain how we're able to achieve this. If you are new to FastAPI, to run this code, you have to first set up your virtual environment so that you can successfully run this code. To do that, run the following command on your terminal. After setting up the virtual environment, then let's activate our virtual environment. We have a virtual environment set up successfully. So now to run your FastAPI code, you have to run the following FastAPI dev.main.py. You can see we successfully run our FastAPI application. Let's proceed to explain the code. Here we implemented a role-based access control RBAC using FastAPI and KeyCloak. It uses JSON Web Tokens JWT for authentication and role-based permissions to protect API endpoints. We are starting with the imports at the top of the file. Let me quickly break this down for you. JSON and typing. This helps us manage data structure like dictionaries and lists. And we import HTTPX. This library is used to make HTTP requests to fetch data from the KeyCloak server. Then we import FastAPI, depends, and HTTP exceptions. These come from FastAPI and help us define APIs, undo dependencies, and raise errors when something goes wrong. Likewise, we import OAuth2 authorization code bearer. This is a helper class for handling OAuth2 flows like authentication. From JOS, we import JWT and JWK. These are critical for decoding, verifying, and handling JSON Web Tokens. And also we import JWT error from JOS exception, which is used to handle JWT errors. Finally, we import base model from Pydantic, which we will use to validate data models. Here, we define the KeyCloak server base URL, then the rem name, which is a logical space in KeyCloak where all authentication happens. And also the client ID, which is like an identifier for the FastAPI app in KeyCloak. Next, we built the JWKS URL. This URL is crucial because it points to where KeyCloak stores public keys for verifying tokens. And also we set up the OAuth2 authorization code bearer. This handles two things. The authorization URL, where users log in and authorize access. The token URL, where FastAPI fetch the user's token after login. We set auto error to false to customize error handling later. Now we initialize our FastAPI. This is a core object where we define our API endpoints. Here's where the magic happens, validating JWT. The validate token function is a bit long, so let's walk through it step by step. Here, we are making an asynchronous HTTP request to fetch the public keys from KeyCloak. These keys will verify the token. The token contains a header with a KID field. This tells us which public key to use for verification. Here we search the JWKS for the key with the matching KID. Here we convert JWK to RSA public key. Then we verify the token. Then we verify and decode the token. Here we construct the public key. Then here we verify and decode the token. Here we get the username and rows which are used for RBAC. Then we define the function to get the current user. Now comes the role-based access control. The AskRow function looks like this. Now comes the role-based access control. This checks if the user's rows include the required rows. If not, it raises a 403 forbidden error. Here's a public endpoint created. This endpoint can be accessed by any user. And also we have the protected endpoint. This protected endpoint is only accessed by an authenticated users. Can only be accessed by an authenticated user. And also we have the admin only endpoints. This include the CRUD operation for items DB, and this all require the admin role, so it can only be accessed by the admin. This endpoint can only be accessed, which is accessible by anyone that has the developer's role. This developer's endpoint can only read items, ensuring a read-only role. Now that we successfully explained the code, now let's go and test our code. We are going to test everything in Postman. Firstly, let us test the public endpoint. You can see this is a public endpoint which is accessible to everyone. So now let us test the protected endpoint. You can see it said not authenticated. You'll be like, how did you get your access token? So to do that, we created a confidential client, right? Which has this client ID. Then you go to your KeyCloak administration console to copy the client secret. So to get the access token, use this KeyCloak URL that points to 8080, which is a KeyCloak development URL, REM's FastAPI, which was the REM name I created, then protocol OpenID connect token to generate token. How to find your client ID and the credentials and the client secret. Navigate to your KeyCloak administration console. Then it's required the client ID. Here is the client ID. Then client secret. You click on the credentials here. You can see it. So when you go to the credential tab, copy this secret. Then you paste it here. You set the scope to be OpenID. Username, the user that was created earlier for the administration role. We have two users, which is Anne and Bob. We've set Anne to be the admin, while Bob to be the developer. Yeah, we're going to generate a token using Anne credentials. We have Anne username and password. Now it asks for the grant type, which we set password. Let us send this. It's going to generate a new token. All we need is this access token. Copy the access token, then go back to the protected endpoint that we are trying to test. Now that we've generated the access token, let us use it in the protected endpoint. So we set this to bearer token. Now let's change this to the new token generated. Now send. Return a response status 200 and with this data. Now let us test one of the admin endpoints. To test for the admin endpoint, the expected data here is JSON and the expected value is name, description and price. Now send. It said invalid token signature has expired. That means we have a token. The token I used before recording this video. So now let us paste the token that was generated earlier to see if we can still use it here. Now let's click on send after pasting. You can see it said invalid token. It's because it expires every 3 seconds. So now let's go and generate a new token. We copy the access token again. Let us paste the new generated access token here. It works successfully. Item t-shirt created successfully. You can also test every other admin only endpoint using this process. Now, lastly, let us test the developer endpoint. Now, to test for the developer endpoint, if you paste in the admin access token, it's going to say forbidden because you are trying to log in as a different user, not as a developer. Let us try to generate the correct token by logging in as the developer. Now let us sign in as developers so that we can use the token for the developer endpoint. So now we go back to the KeyCloak admin console. We created a user called Bob, right? And it has a role of developer. Now we have to copy the username. I can't remember the password I set for this. So let us reset the password. So the new password, let's say 12345. 12345. So let's turn this off. Then let's save the password. So now let's go back to our Postman to sign in to generate the token. Here we're going to change this username to Bob. Then the password, you're going to add 5 to make it. We've generated a new access token and we've signed in as the developer. So now let's copy this access token to test with the developer endpoint. Get this off, then we'll paste this. You can see our endpoint works successfully with a status of 200, returning the item data. We have covered a lot of ground, so let us quickly recap the key best practices. Authentication best practices. HTTPS is a must. Always prioritize secure communication by using HTTPS for all token exchanges. Embrace OAuth 2.0 with PKCE for public clients. Implement OAuth 2.0 with the proof key for code exchange PKCE flow to enhance security. Rotate client secrets regularly. Strengthen your security posture by regularly rotating client secrets to minimize the impact of potential breaches. Server-side JWT validation. Always validate JWT tokens on your server side using the public key provided by KeyCloak to ensure their authenticity. Authorization best practices. Leverage KeyCloak rules. Utilize KeyCloak's robust role-based access control system to define granular permissions for your users. Scope your API endpoint. Define clear scopes for each API endpoint to control the level of access granted to different applications. Resource-based permissions. Implement fine-grained control by defining permissions at the resource level, allowing for highly customized access rules. Utilize KeyCloak's policy evaluation to thoroughly test and validate your authorization rules before deploying your application. By following these best practices, you will build a secure, scalable, and maintainable foundation for your FastAPI application. Alright, we have explored how KeyCloak can significantly enhance your FastAPI application. Let us recap the key takeaways. KeyCloak simplifies, streamlines authentication and authorization, freeing you to focus on core application logic. Role-based access control enhances, provides a robust and flexible mechanism for managing user permissions, improving security and scalability. Standards compliance approach ensures interoperability with other systems, making it easier to integrate with existing infrastructure. Thanks for watching. If you found this video helpful, please like and subscribe for more content on FastAPI, KeyCloak, and other existing technologies.